Welcome to Mr. Brandt's 5th grade everyday math review. In this video, we're going to be going over lesson 3.7, which is dealing with fraction estimation using or with benchmarks. And so when we're talking about benchmarks, we're talking about 0, 1/2, 1/2, 1 1/2. Okay, those would be considered our benchmark fractions. So let's look at the problem here. 7/8 plus 4/5. So one way you can think about this is by looking at the numerator compared to the denominator. So eighths is how many total pieces we have. If we have 7 of the 8, that's almost the whole thing. So we could estimate that as being about 1. Same thing with 4/5. 4/5, there's 5 total pieces. We have 4 of them. That's almost the whole thing. So that would be 1. So 7/8 plus 4/5 is going to be about the same as 2. It's about the same as 2. For our next sample problem, we're going to do 1 3/7 subtract 1/6. And up on the number line, I've got this, after 1, I've got it marked off into sevenths. So you can see this is 1.5, and this is not exactly perfect, but so it'll be 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, and then 2 would be the same as 1 7/7, or you could even say 14/7. But if we look here, 3/7 is pretty close to 1.5. So we're going to think about 1 3/7 as being our benchmark fraction of 1.5. Then from that, we're going to take away 1/6. And if I divide this part into 6, so this would be 1/6, 2/6, 3/6, 4/6, 5/6. And really, I probably should have made another number line, but this will still give you an idea. So I've got 1/6 is pretty close to 0. So we're going to think about this as, we're going to think about 1/6 as being close to the benchmark of 0. So 1.5 subtract 0 is 1.5. So 1 3/7 subtract 1/6 is going to be about 1 1/2. Now it's not going to be exactly that. Again, we're just trying to get close to our answer. It's really going to be somewhere between, it's going to be between 1 and 1/2. But for the math we're doing for the homework tonight, you can think about the problems in that way. For the next portion of the homework, there's a couple of story problems, and we're going to use the same information, but think about it in a different way. So we're going to start and we're going to deal with hot dogs. So we're going to say that Joey, in 1 minute, ate 2 5/6 hot dogs. He ate 2 5/6 hot dogs. And Matt, in 1 minute, ate 1 4/9 hot dogs. 2 5/6 and 1 4/9. So let's say our problem was this, that in 1 minute, Joey ate 2 5/6 hot dogs, and Matt ate 1 4/9 hot dogs. How many hot dogs did they eat in all? So for that problem, we're combining their two results to see how much they ate together in all. So because of that, that is going to be an addition problem. So 2 5/6 plus 1 and 4/9. And again, we're estimating using benchmarks. So 5, 6, 5 is almost all of the 6 pieces. So that's going to be close to a benchmark of 3. 1 and 4/9. If there's 9 total pieces, 4 is about half of that. So this benchmark is going to be 1 and 1/2. So we're going to take those two benchmarks, 3 and 1.5, and we're going to add them together because we're combining. So 3 plus 1 and 1/2 is equal to 4.5. So how many hot dogs did they eat in all? They both together ate about 4.5 hot dogs. Now let's think about that in a different way. Let's think about that with this. So Joey ate 2 and 5/6 hot dogs, and Matt ate 1 and 4/9 hot dogs in a minute. How many more hot dogs did Joey eat than Matt? So for this one, it's a comparison. We're comparing how much one person ate compared to the other. And to find that out, we're going to do some subtracting. Maybe should I just left that all up there? So we've got 2 and 5/6, which we said is close to the benchmark of 3. And 1 and 4/9 is close to the benchmark of 1.5. And since we're comparing the two, we're going to subtract. So 3 subtract 1.5. There's a number of ways we could think about this. Let's take 3 or 1 away from 3. So 3 subtract 1 is 2. Then if we take a half away from that, that's going to be 1.5. So 2 and 5/6 subtract 1 and 4/9. If we're thinking about this in terms of benchmark fractions, it is going to be about 1 and 1/2. And let's finish up with the practice section for lesson 3.7. And the practice section for this one is talking about volume. And we know that volume has two formulas. And the first one is, well, not necessarily the first one, but one is volume equals length times width times height. And volume can also equal big B, and the big B is the area of the base. So area of the base times the height. So let's say that they gave you a box that had the dimensions of 3 inches for the length, 4 inches for the width, and 2 inches for the height. We could take those, multiply them together. 3 times 4 is 12, and then 12 times 2 is 24. So the volume would be 24, and since it was inches, and that volume is in is 3 dimensions, that would be inches cubed. Inches cubed. This little 3 shows this its third dimension. Okay, for volume, or excuse me, if we're dealing with the area of the base, let's say that they gave you another box and they told you that the area of the base was 25 inches squared, because area is 2 dimensions, so inches squared. And let's say the height of that box was 5 inches. So 25 inches squared times 5 inches equals 125. And since that's volume, it's going to be inches cubed. So 125 inches cubed. That was a little bit long of the video, so thanks for sticking it out. Make sure you, if you're confused on any of these, make sure you get some help from one of your teachers. Thanks for watching.